Hello everyone, welcome to Wallah YouTube channel. I hope everyone is doing great. So today we are going to proceed with precipitation chapter. Okay. Before moving further, firstly everyone kindly comment that I am fully visible and audible to you all. Kindly comment. Then we'll proceed with our subject. Okay. So in the last class we have already discussed the types of precipitation. I hope you remember it. Firstly we'll have a quick recap of what we have discussed till last class. After that we'll proceed further. Okay. Kindly comment everyone. Okay, wait a second. Okay, so we have discussed till last class what things we have discussed. In the last class we have solved some great examples of catchment area. Based on your catchment area we have solved some questions. I hope you remember it. Then we have solved this entire catchment area concept. Runoff coefficient, we have discussed the importance and significance of runoff coefficient. I hope you all remember that. After that we have discussed residence time concept also in the given class, and then we have discussed how, or we can say what are the causes of precipitation, that we have discussed in yesterday's class. So basically we have discussed that whenever vapor pressure or humidity or moisture will be more, then you will see that precipitation or condensation will start to happen. Yes or no? Otherwise, when your vapor pressure or moisture is less in the atmosphere, then you will see that no precipitation will take place, and in that case evaporation will take place. Okay, opposite to condensation is your evaporation. So basically sir, we have discussed that moisture should be more, moisture level should be high, and secondly temperature should be at a lower level. Okay, so temperature should be at a lower level. Why? Because when temperature drops, saturation vapor pressure or the moisture holding capacity of atmosphere goes down, that we have discussed yesterday. Okay, so you need to remember that two basic causes are more moisture and lesser temperature. Lesser the temperature, more the moisture, you will see more precipitation is there. That means when relative humidity is tending to 100%. I hope you all remember this. Yes or no? Kindly comment everyone, then we'll proceed further. Okay, great. So now everyone kindly comment what are the types of precipitation that we have discussed yesterday. So I have told you about convective precipitation. I hope you all remember that convective precipitation. In this, what happened, sir? In this one, convection currents was set up because of the temperature difference. Because when the air which is near, or you can say the air which is in the vicinity of the heated up ground, that air is lighter and it will try to go up. Yes or no? When it goes up, cold air settles down and fills, or you can say replaces it, and in a sequential manner you will see that this convection cycle is set up. Yes or no? That we already discussed. So because of this convective cycle, whenever the warm air goes up, it expands, and when it expands it will adiabatically condense. Okay, why adiabatically? Because it does not exchange heat energy. Only because of expansion temperature drops. Okay, work done, or you can say work is being done by this expanding air, expanding warm air, and because of which temperature goes down. Okay, so sequentially you will see that clouds are formed. So I hope this is very clear to you. So this is basically because of temperature difference and convection currents being set up there. Then the next one which we discussed was your orographic, in which what we saw that moisture laden winds are forced to move up any orographic barrier. Okay, be it mountain, hill, or any kind of barrier. When your moisture laden winds are forced, then you will see that when they are forced up, obviously temperature will drop, and you will see condensation happens, and precipitation or rainfall happens on the windward side only, not on the leeward side. Okay, so this you need to understand. So this was your orographic precipitation. I hope this was very clear to you. Then we have cyclone. Cyclone, sir, is nothing but a low pressure region. Cyclone, in the center there is a low pressure region, because of which, sir, air from high pressure zone rushes into the low pressure area and it forms a circular motion, and because of this circular motion wind is not able to enter inside, and it will continuously move in circular fashion, and it will tend to rise, and when it will rise again temperature will drop, and you will see that again precipitation will happen. Okay, again you will see that here clouds will happen, and see there is a pattern to rainfall intensity when you will radially move outwards from the center of cyclone. I hope you remember this. Then we focused on the direction. Okay, cyclone in northern hemisphere, its direction is see, we have discussed this. Let me show you the question which has been asked in GATE examination. Let me see if you are able to solve it. Okay, see, the direction of cyclone is important because once it has been asked in your GATE examination. Okay, can you tell me? Can you tell me what is the direction of tropical cyclone? See, there are two types of cyclone. One is your tropical cyclone and another one is your extra tropical cyclones. Okay, so tropical cyclones basically are originated in tropical region. What is tropical region? I told you about southern and northern hemisphere. See, this is your planet Earth, this is equator, this is tropic of Cancer, this is tropic of Capricorn. This entire region is your tropical region. So whatever cyclones are getting generated here in this region are tropical cyclones only, and the cyclones which are being generated, you can say beyond this zone, are extra tropical cyclones. So here in this question they are more interested in tropical cyclone, but more or less it's a cyclone. Okay, so can you tell me the answer? Can you tell me the answer here? Hello sir, I'm currently studying maths with your lectures. Just here to say you're great, Sirji. Thank you. You're welcome, dear. I hope you are enjoying the lectures. Okay. Wait a second. So can you tell the answer? So in yes, so what will be the answer? Yes. Tropical cyclone is a low pressure zone. First, you all know that at the eye, at the center, we have low pressure zone. So obviously, these two options will get cancelled. Answer is low pressure zone, and that too in anti-clockwise direction. Okay. Yes. All those who are guessing answer as C is absolutely correct. Absolutely correct, because I already told you that in northern hemisphere, see, they are asking in question, they are asking about northern hemisphere only. Yes or no? In question, they are asking about northern hemisphere only. You can see here. Okay. So in northern hemisphere, we all have already discussed that the direction of cyclone is anti-clockwise. So you need to remember. And if you remember only one direction, just do the opposite of that. You will get the direction in the southern hemisphere. See, here it is anti-clockwise, here it is clockwise. Opposite to anti-clockwise, again we have clockwise. Okay, likewise you can remember. Then at the last, we have discussed about frontal precipitation. See, frontal precipitation is nothing. Only you need to understand that whenever warm air and cold air will collide, okay, when warm air meets cold air, okay, whenever warm air meets cold air, the interface, see, the interface at which they meet, that is known as front. Okay, that's why the name frontal is there. Okay, the interface at which they meet, the interface at which they meet, the interface at which they meet is known as front. Okay, is known as front. And you should appreciate the fact that at the front only, okay, at the front only precipitation will happen. Okay, at front or at this interface precipitation will happen. Okay, with little thunder also precipitation will occur. Precipitation will occur. I hope this is very, very clear to you. Yes or no? Perfect. Great. Now we'll proceed further, and today in this lecture we are going to cover what topics? Tell me, sir. So in today's lecture, basically we are going to cover basically measurement of precipitation. Okay, forms of precipitation are also left from the last class. So firstly, we are going to discuss about forms of precipitation, and then we are going to discuss about the measurement, how we measure precipitation and why we are interested in measuring it. That we have to discuss today. What are the instruments? Okay, is my rain gauge a recording type or non-recording type? What are different instruments? Okay, and what we'll do with the help of that rainfall data, that we are going to discuss in today's lecture. I hope everyone is with me. Okay, great. So we'll proceed with forms of precipitation in this class. Okay, kindly try to interact, because when this session will be more participatory, it will be very, very beneficial for you all. I hope you will answer me. Okay, now four forms of precipitation are very, very common, but total here we have 6 forms of precipitation which are basically given in your standard books. Okay, but we are more interested in the 4 because questions have already been framed in any kind of examination only from those 4. Okay, like glaze has never been asked. Okay, glaze has never been asked. Sleet, you will see that it is also not asked. Basically rain, snow, hail and drizzle, some questions have been framed from these areas. Okay, so the very first form of precipitation you all know, deposition of water. Listen very carefully. What is precipitation? Precipitation is deposition of water or deposition of water at the earth surface. In which form? You need to understand, sir. Water which is coming from the sky, or you can say which is falling from the sky, clouds basically, that water when it reaches the earth surface, is taking what form? Sir, it can be in form of snow, it can be sleet, it can be rain, hail, drizzle, glaze, any kind. Okay, so based on what we are seeing at the ground, based on that we have 6 forms. No matter what, you need to understand one thing, that when precipitation is leaving from cloud, what form is there, in that we are not interested. We are not, let us take an example. Just assume that when this drop of water has left the cloud, okay, it is in liquid state. But imagine when it is coming on ground, and because this ground is very cold, but this drop of water, when it has reached your ground, it has frozen. So when it has frozen on reaching the ground, I will say that this is a sheet of ice, it's not water anymore. So this form of precipitation will not be counted in rain, but it will be counted in glaze, because water freezes on contact with cold ground. Okay, so what is the ultimate form on reaching the surface? In that we are interested, and based on that we will distinguish different forms of precipitation based on that what we are seeing at the surface. In what form your water has deposited on the earth's surface, in that we are more interested. Now based on that we have basic 6 forms of precipitation. The very first one is rainfall. So what is rainfall? Kindly comment everyone. Now tell me, what is rainfall? Very simple, basic, everyone must have seen. This is the most common form of precipitation which everyone must have witnessed on this planet earth. I hope this is very clear to you. You all are commenting or not? So tell me, what is the drop size of rainfall precipitation? Can you tell me? Kindly comment. Try to comment, because this session has to be participatory in nature. Yes or no? Yes, perfect. Yes, the drop size is absolutely correct. It is ranging from 0.5 to 6 mm drop size. The droplet size is ranging from point. Everyone try to comment. Kindly comment so that you are able to remember it simultaneously. Yes or no? Perfect. Great. So you need to understand that the drop size is, yes, 0.5 to, yes. So basically you will see that the most dominant or prominent one in which generally precipitation happens is your rain only. The next one which we have here is snow. So what's snow? Snow is nothing. Snow is very simple. See, you must have seen that in hilly areas sometimes snowfall happens. So that snow which is falling in fresh form is very soft. Basically you must have seen small children's, basically what they do, they make balls out of fresh snow and they throw at each other. Okay, that is fresh snow. That is very light. The density is 10 times less than that of water. Kindly comment the density of snow. Its density is 0.1 gram per cc. It is very light. It's pure white in color and it is opaque. You cannot see through it. That is perfectly white. Yes or no? Have you seen it? Have you seen it somewhere? Yes or no? So tell me, what is the average density of snow? See, whatever bullet points I have added here are most important. They can be asked in any of your examination. Yes or no? So you need to understand it. So snow density is how much? Sir, 0.1 gram per cc, and it is opaque. That you need to appreciate. Okay, it is opaque here. Perfect. It's very light in nature. It's opaque. We cannot see through it. It's perfectly white, pure white. Okay, we can say it. Now, next one is sleet. The third one, which you can see here, is sleet. Now difference between snow and sleet is, see, in sleet also you are seeing it is a mixture of snow and rain. See, cartoons, you must have seen some cartoons in which you have seen that stars are falling, small stars are falling. What are those stars? Those are nothing but whenever transparent, not we can say perfectly transparent that you can see through it, okay, perfectly, but yes, we can say it is little transparent or it is partially opaque. And I think some connection issue was there, but I hope it has resolved now. So we were discussing snow and rain. So this snow is what? This snow is little translucent. Okay. Have you seen the ice cubes in your fridge? Yes or no? That is nothing but this sleet kind of snow. Okay. So I hope this is very clear to you. So mixture of snow and rain is what? It's sleet. And in this you will see that small pellets of snow are falling whose size are less than 5 mm. Okay, I hope this is very clear to you. Now the next one which we have here is hail. Okay, next one which we have here is hailstorm. In hailstorm you need to appreciate that large pellets of size ranging between 5 to 50 mm. See, hailstorm is very destructive in nature. Why? Because the farmer crops are destroyed. Okay, farmer crops are destroyed when hailstorm is there. So you need to understand that hailstorm is very destructive to farming. Okay, because crops are destroyed, so it's not useful. Obviously hailstorm causes huge destruction, so it should we should pray that hailstorm does not happen because it causes huge destruction in fields. Okay, so hailstorm you all know, you must have seen. And in this one we have bigger snow masses. Okay, bigger snow masses which on falling on earth causes huge destruction, so not so good. Hailstorm you must have studied also. Then we have drizzle. See, drizzle means very minute droplets. Okay, see, rain size is 0.5 to 6, that you can appreciate here. Okay, rain size is 0.5 to 6, but drizzle is even smaller than 0.5. Wait a second. Yes, so drizzle is even smaller than 0.5. Okay, 0.5 mm is even smaller, very tiny droplets of water. And in exam, one state examination, it has been asked like what is the intensity of drizzle. Okay, so you need to remember, whenever intensity of drizzle it is asking, it is simply how much? 0.1 centimeter per hour. 0.1 centimeter per hour, it's very less. Okay, and sometimes you need to remember that 0.1 centimeter is nothing but 1 mm only, 1 mm per hour. Okay, so that whenever intensity of rainfall is even less than 1 mm per hour, that is nothing but drizzle. Very minute droplets are falling. Yes or no? So I hope this is very clear to you. Then at last we have glaze. Glaze means simply we have a very cold ground. Okay, try to imagine we have cold ground, and whenever water will come into contact with that cold ground, what will happen? We have a pure sheet of ice. We have a pure sheet of ice, that is nothing but glaze. Okay, so I hope this is very clear to you. So at the end, whatever form deposits on earth's surface, in that we are interested. Sometimes we can see ice sheet is there, that is glaze. Sometimes I can see very small droplets has fallen, so that is drizzle. Normal droplets are rain. Okay, and you need to understand that rain drops are not bigger than 6 mm. You must have thought that's why raindrop size are not bigger than 6 mm. Why? Because now that big drop will automatically break into smaller drops. Okay, if your raindrop size is more than 6 mm, then you will see that it is so huge that in order to increase the, you can say, it will, that raindrop will not be stable. Okay, it will become unstable and it will break into smaller droplets. Okay, so raindrop more which is having size more than 6 mm is not stable, so it will ultimately break and you will see a size which is in this range or it is in this range. Okay, so this is it. And trace is what? Trace is drop size is even less than 0.1 mm, very minute droplets. Okay, that is trace. So trace is also a kind of drizzle only, in which we have even smaller what? Droplets. Okay, so I hope this is very clear to you. One more thing which is left here, which you need to remember, is your classification of rainfall. Okay, we have rainfall here, we can even further classify it. You need to remember it. So let us draw a very small table here. See, I am trying to cover each and every point here in the class so that nothing is left out. Wait a second. Okay, so this is your simple classification of rainfall. Okay. So you need to understand, first we have light rainfall. Okay, first we have, see, we have basically three kinds of rainfall based on intensity. Based on intensity of rainfall, based on intensity of rainfall, we have three kinds of rainfall. The very first one is light rainfall, then we have moderate rainfall, and at last we have heavy rainfall. Okay, sir, clearly understood. Now, what is light rainfall? Light rainfall is what? When we have intensity less than 2.5 mm per hour. So obviously that will be treated in light category. Yes or no? Okay. Now, what is moderate rainfall? Sir, in moderate rainfall, the intensity of rainfall is 2.5 to 7.5 mm per hour. Okay. So this is moderate. And when intensity is even more than 7.5 mm per hour, that is your heavy rainfall. Okay. I hope this classification and entire form is fully clear to you. Okay. So now we'll move further. Now we'll move further and we'll try to discuss measurement of precipitation. Okay. So I hope this forms of precipitation and entire thing, all the factual data is fully clear to you all. Okay. So now we'll proceed further. Now we'll proceed further and we'll move on to measurement of precipitation. Okay. Which is the ultimate objective of our today's class. So I hope you have understood till here. Now what we are going to discuss we are going to understand how rainfall is measured. You need to understand rainfall is measured by an instrument which is known as rain gauge. Okay, see, rain gauge, you can call it as rain gauge, you can call it as pluviometer, you can call it as ombrometer, hydrometer. See, all are one and the same. Rainfall or precipitation is basically measured by ombrometer, hydrometer, pluviometer, rain gauge. All are one and the same. See, you need to remember all these names because any name you can witness in your examination. Okay, any name can come across. So you need to remember pluviometers. Okay, whenever you will hear the word pluvio, it is simply referring to rain only. See this hydro word, ombro. Okay, rain. All are one and the same. Pluvio. Okay, so these are different words in different languages. So ultimately, all are one and the same. Okay, sir. Now, what are different kinds of rain gauges that we need to understand? Okay, we have different kind of rain gauges. Listen very carefully. This topic is important because Simon rain gauge has been asked in examination. See, there are two kinds of rain gauges. Okay, sir. Tell me. See, there are basically two kinds of rain gauges. See, one is your non-recording rain gauge. One is your non-recording rain gauge. Listen very carefully. Can you tell me the difference between non-recording and recording rain gauge? Kindly try to comment if you know it, or try to guess it. Simply try to guess it. No matter if your answer is wrong, just try to tell me the difference between non-recording and recording. Can you tell me? Try to guess. Try to guess what is the difference between non-recording and recording rain gauge. See, rain gauge is simply measuring the amount of rainfall. Yes or no? Now, sir, the meaning of recording and non-recording is if your rainfall data, okay, if your rainfall data is measured with respect to time, temporal variation is there. Okay, with respect to time, rainfall data is available to you, then I will say that that kind of rain gauge is recording type, because you will exactly come to know that rainfall is happening at 11 p.m, 12 a.m, like that. Okay, exactly at 1 p.m, 2 p.m, like that. So at what time rainfall has happened and how much rainfall has happened, that data, if it is available to you, like simply you need to understand, we have a graph, and in that graph rainfall distribution with respect to time is there. whenever rainfall distribution with respect to time is there, I will call that rain gauge as recording rain gauge. And if I don't know, exactly at what time how much amount of rainfall has happened, and we only know the total rainfall in the total day, okay, in entire day how much rainfall has happened, that we know, so that is your non-recording rain gauge, because it does not gives you the variation with respect to time. Let us try to understand with different types of rain gauges. Okay, first I will give you some examples of non-recording rain gauge, and then I will give you examples of recording rain gauge. But let me first write the definition of it. I hope this is very clear to you. Okay, so non-recording is what? Non-recording means rainfall variation or simply let me write here in this one that recording rain gauge measures rainfall variation over time or with respect to time. Understood, sir? With respect to time. So I hope this is very clear to you. So non-recording rain gauge is what? That will not measure, okay, it does not measures temporal variation or timely variation. It does not measures timely variation, and it will simply give you the total amount of rainfall. Okay, this will simply give you the total amount of rainfall that has happened in entire day. Now let me show you an example. See, one word you must not, timely, you all know temporal variation is timely variation only. I hope this is very clear to you till here. Okay, yes, so now let me show you example of non-recording rain gauge. Kindly comment everyone the example of non-recording rain gauge. See, this is very important because it is used in India. Okay, you can see the picture also here. I will explain it to you. First, everyone try to comment the example of non-recording rain gauge which is used in India. If someone asks you like which is the non-recording rain gauge used in India, you need to comment the answer here. So what is that rain gauge? Kindly comment everyone. What is that rain gauge? Perfect. Simon's rain gauge is the correct answer, which is being used most dominantly in India. Okay, now you need to understand the rainfall in rain gauge is measured every day at 8:30 or you can say 8 a.m. Okay, in the morning you will see here we have a cylinder. Okay, you can see here we have a metallic cylinder. In this, rainfall is being measured every day at 8:30 a.m. So let me show you more clear diagram here. See, this is a diagram which is available in your standard books. Okay, so you can see that we have a masonry foundation block in which we generally attach it. Sometimes we attach it with the help of these stands. Below it you can see the masonry block is there, otherwise it is fixed in it. Okay, we have any amount of options. Okay, we can do anything, but ultimately this rain gauge has to be fixed. Understood, sir? Now what we can see here at the outmost portion, okay, the outermost portion is what? Is your metallic casing. In which inside is your glass bottle. Okay, outside we have metal casing and in the inside we have a glass bottle, and at the top of glass bottle we have a funnel here. Okay, you can see we have a funnel here, and see, we try to install this rain gauge in an open area. So that more amount of rainfall, or you can say the correct amount of rainfall is going into this bottle. Simply you need to understand that the flow of rainfall or the amount of rainfall which is going inside should not be influenced. Okay, that's why we try to keep it in open area. Yes or no? Otherwise, if it is near buildings, then obviously that buildings or obstructions will hinder with the you can say flow of rainfall. So that's why it is kept in open area. Okay, that I will write also. So this is your metallic bottle, and from this funnel your water will go inside. Okay, so in one day, in 24 days, you know that you come every day at 8 a.m. or 8:30 a.m., whatever is the time in the morning, you come once and you will note the reading. Let us say this much amount of water has collected here. So what I will do, I will bring out this bottle, I will pull out this glass bottle, and in this measuring jar I will pour this water and measure the amount of what? Water. Okay, and measure the amount of depth of water. Okay, so basically I can say 5 mm of water has fallen that single day, 6 mm, 10 mm, 1 centimeter, like that. Okay, so how much is the depth of rainfall in 24 hours? That I will note every single day, at every day wherever there is rain gauge, or you can say whenever there wherever we have a station, there is a basic responsibility that every day we have to note down the reading. But you need to appreciate the fact that in Simon rain gauge we does not get the reading, at every hour of the day. We don't know that this rain has happened at 11 p.m. or 2 p.m. or 3 p.m. We are not coming to this conclusion. We only know that rain has fallen, no matter at what time it has fallen, no matter what, but it has fallen at some time. But when we are coming after 24 hours every day at 8 a.m. okay, or 8:30 a.m., whenever we are coming early in the morning, I am seeing that this much rainfall has happened. But exactly at what time? Exactly at 10:45, 1 p.m., 2 p.m., we don't know it. Okay, that's why this is non-recording. That's why it is non-recording. If it would have been your recording rain gauge, then we would come to exactly know that this rain has fallen at 11 p.m. or 12 p.m. or whatever. Okay, so here we don't have the time data. That's why we can say that it is a non-recording type. So I hope this schematic diagram has given you the basic idea. Now more things which you have to understand from here. So rainfall is measured every day at 8:30 am. So this we have understood. Now, sir, tell me what is the diameter of this rain gauge? Okay. See, if someone asks you, like what is the diameter of this Simon rain gauge? What is the diameter of this Simon rain gauge? You need to tell. Okay, what is the diameter of this rain gauge? So you need to say it is 5 inch. It is sometimes also called as 5-inch rain gauge. Okay, why? Because Simon rain gauge is also sometimes referred to as 5-inch rain gauge. Why? Because the diameter of collector, the diameter of receiver is 5 inches. That's why it is sometimes also called as 5-inch rain gauge. If you will convert this 5 inch into your centimeter, it is nothing but 12.7. Okay, let me write here. Diameter is what? 5 inches, or sometimes you can call it as 12.7 centimeter or 127 mm. Understood, sir. Now, what is the height of this rain gauge? Okay, Simon rain gauge. What is the height, sir? So height of rain gauge is what? 30 centimeters. See, this data you have to remember. See, Simon rain gauge is only one which is being used in India, so you need to remember it. Okay, perfect. 127 mm. Okay, clear. So height of rain gauge is how much? 30 centimeter. Diameter of rain gauge is how much? 5 inches. Okay, so this is your data, diameter and height. Now next one is, see, this rain gauge has to be placed in an open area. Okay, this rain gauge, it should be placed in an open area. It should be placed in an open area, and it should never be placed under a tree or on the roof of a building or near the building. It should never be placed in such places. Okay, it should never be placed. Let me write it here only. It should never be placed. It should never be placed. Where? It should never be placed near the building. It should never be placed near buildings, under a tree, near. It should never be placed near buildings. It should never be placed under a tree. It should never be placed. You can say it should never be placed near buildings, under a tree, or you can say over the roofs. Okay, or on the terrace. We should try to ensure that it is placed in an open area with no obstructions. Okay, obstructions, buildings should be far apart. Yes or no? Tree should not be there. So this is the ultimate objective. Okay, so I hope this is very clear to you. So it should never be placed in such places. So this is your ultimate aim. Now we have one condition here. We have one condition here which is mentioned in IS 4987, which is your Indian code of your rain gauges. Okay, IS 4987. So in that code, it is written that no object, listen very carefully, this question or this exact line, this codal provision has been asked in your engineering services 2019 paper in preliminary exams. Okay, so very simple statement, just try to understand it. It is saying that no object should be nearer to instrument rain gauge than 30 meter or twice the height of obstruction. What does it mean? See, the meaning of this is that, let me explain it to you with the help of an example. No matter what, see, two conditions are there. Let us take an example. Let us say we have a building. Let us say we have a building of, take example, let us say we have a height of this building as 25 meter. Okay, this is, let us assume this is an obstruction. Okay, this is a building. Let me draw windows only. Okay, so imagine this is a building. Perfect. So this is a building whose height is 25 centimeters. So tell me how far from this building, can you tell me how far from this building the rain gauge should be placed? Can you tell me this? See, condition is 30 meter or twice the height of obstruction. So we have two conditions here. We have to place it 30 meters apart or twice the height of obstruction. Now what is the twice of 25? Multiply 25 by 2. So it will be nothing but 50 meter. Okay. 50 is what? Or let me write twice here only. Twice the height of construction or twice the height of building, it is nothing but 50 meter. We have to use the bigger one because we have to ensure that object is not near than 30 meters or it is not near than twice the height of obstruction. Yes or no? So the answer will be, what? Tell me. The answer will be, tell me how much. So now if you want to install a rain gauge, if you want to install a rain gauge here, sir, I will install a rain gauge here. But how much distance should be there from here? Sir, it should be not less than, this distance should not be less than 50 meters. It should be even more. So this is the codal provision. Twice the height of building or 30 meter, whichever is more, we'll use that. Okay. You need to understand that we have to use the maximum one. Okay. Let me write here. No object should be nearer to instrument than 30 meter or twice, whichever is more, whichever is greater. Whichever is greater. So remember this. Okay. I hope this is very clear to you. So we'll move ahead and we have covered the first non-recording type of rain gauge, the only one we can say, Simon rain gauge. Okay, so Simon rain gauge is fully clear to you. Like what are the conditions, that we have also understood. What is the diameter, height, and how it should be placed, that we have also discussed. Also one more thing is there. Generally what happens, wherever we install this rain gauge, in the surrounding we make a fence. Okay, we make a wiring fence so that no animal is getting inside and disturbing those instruments. Okay, so that no animal disturbs this instrument, we are ensuring that we have a fence also. Okay, you need to understand that this is a 60 by 60 by 60 centimeter masonry block which is being surrounded, or we can say it is being flanked or encircled by a 5.5 meter by 5.5 meter fencing. Okay, let me write here, it is covered by, this instrument is covered by, or you can say surrounded by, 5.5 by 5.5 meter fencing, obviously to prevent any kind of animal attack on this instrument. Okay, so it is covered by 5.5 meter wire fencing. Okay, so that no animal is getting inside. Also you need to understand that this instrument should not be installed at a very you can say at a much height, or you can say it should not be placed near to the ground. It should have an optimum height. Okay, so all these things we should keep in mind before installing a rain gauge. So I hope this is very clear to you. So is it clear? Kindly comment, then we'll proceed. Sir, how will reading will be take? No dear, generally we install rain gauges in those area. You should appreciate the fact that all the population does not live in rural areas. Okay, see, everywhere that there is no crowd, generally rain gauges are installed in remote locations, okay, where there is no obstruction. Obviously in city area where there is crowd, obviously we will not install rain gauge there. Yes or no? This is the point which I am trying to explain. Yes or no, Sushil? Sarthak, don't worry, I will try. Okay. Okay, so now we'll proceed further. Okay, now we'll proceed further and move to the recording rain gauges. Okay, now the non-recording one is over. Now we are interested in recording rain gauges. See, I have already told you what is recording rain gauge. Recording rain gauge is a one which measures temporal variation, which measures the rainfall intensity with respect to time. Okay, how does it measure? That I am going to explain it to you with the help of a example. Okay, first we will see, we have three basically recording rain gauges. First is a tipping bucket, then we have weighing bucket type, then we have your natural siphon type. Okay, we have three rain gauges. Okay, we have basically three kind of rain gauges. So first one is tipping bucket, then we have weighing bucket, then we have natural siphon. So three kind of recording rain gauges are required. So the very first one is tipping bucket rain gauge. See, what is tipping bucket? Need to understand, listen very carefully. Tipping bucket is what? See, this is your rain gauge. At the top we have a funnel, so this is a receiver, or you can simply say it is a collector. See, first let me write down here the very basic point. The diameter of this collector or the diameter of this receiver, the diameter of the receiver is 30 centimeter. The first important point. Okay, so the diameter of this receiver which you are seeing here is how much? 30 centimeters. See, this question has been asked in one state examination. Okay, yes or no? Okay, so this is basically your diameter of your. See, Sarthak, don't worry, don't worry. On Hindi channel, subjects will be running in Hindi only. Okay, on English channel, obviously we have to make sure that subjects are going in English. Okay, so this is English channel, so don't worry. If you want to learn subjects in Hindi, join Hindi channel, Gate Wallah, MEC and XC channel. Okay. Okay, one doubt is here. Difference between AC and DC. AC and DC, see, this is not a physics class. Obviously, it's hydrology, but still I know it, so I will explain it to you in one or two lines. See, in direct current, you know that phases that does not change. Okay, it is not the amplitude is not changing with respect to time. Okay, it is not a frequency driven current. Direct current is simply, it does not fluctuate. Fluctuation is not there. Okay, in amplitude fluctuation you will not see. In AC you all know that fluctuation is there, so that is alternating current. Okay, sometimes current will flow in one direction and sometimes it will flow in another direction, and that happens at a frequency of 50 hertz. That means in a single second current changes its direction 50 times. Okay, it's a oscillating kind of current, so that is simply your alternating current. Okay, so don't worry. Now we are going to come back to hydrology again. The diameter of the receiver is 30 centimeter, that we have understood. Secondly, how it measures. See, you can see we have a bucket here and it is being balanced on a pivot. Okay, on the pivot point, or you can simply see, you must have seen the seesaw kind of thing in your parks when you were small. Okay, when you were in your childhood, you must have seen those okay, merry-go-round kind of thing was there in parks. Okay, we have slides, different kind of slides were there in parks, and we also have this seesaw kind of thing. So it's a kind of seesaw here. You need to understand that whenever, see, we have two buckets here. See, rain is coming and falling into this first bucket. When this when this bucket will have more weight because of this falling water, what will happen? It will tip over. Okay, this bucket will tip over because this is having more weight and all this water will run away. But what will happen when this bucket will tip over? The next bucket will take the position. Okay, you need to appreciate the fact here that right now So right now this bucket is in position and it is collecting water. The moment it is full, it will tip over and the next bucket will come in place and this will receive water now. Yes or no? It will tip over and the next bucket will come in its place. Yes or no? So when it will tip over, what will happen? This bucket will now touch the sensor. See, these are sensors. These are sensors on which it is being rested. So what will happen? First, it will collect all the water. It will tip over. It will touch the sensor. Again, when the next bucket will completely will get completely filled, it will tip over again. So it is like this kind of motion will be there, tip 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 tip, like that. Okay, so why the name tipping is there? Because this bucket will tip over again and again as the rain is continuously falling. Okay, so that you need to understand here. And the moment this bucket touches the sensor, it will give a signal. So you need to understand, see this the wires will carry this signal into the station or simply the lab wherever we are noting the graph. And in that graph exactly, you need to understand that based on this signal a graph is being continuously plotted based on this signal. Okay, so exactly whenever rainfall will happen, this tip thing will happen. Okay, tip over thing will happen, and whenever tip over thing will happen, you will see that because of that we have a graph. Okay, continuous graph. You can say 24 hours. So whenever the rainfall will happen, let us assume that rain has fallen on at 11 a.m. or let us say it has fallen on 1 p.m. Whenever this rainfall has occurred, be it 11 a.m., be it 1 p.m., be it 2 p.m., immediately you will see the graph. That's why we call it as recording rain gauge. Why? Because every time rain is happening, the moment we are getting the you can say signal, and because of the signal we are getting intensity versus time graph continuously over time. That's why this is recording rain gauge, because we get temporal variation here. I hope this is very, very clear to you. Yes or no? Clear? So this is your tipping bucket. Why? Because in this bucket tips over when it is full. See, these small buckets is having a capacity of storing 25 mm of rainfall. Okay, now the last point is, see, these types of rain gauges are basically used, okay, it is used in that places where we cannot go every day. See, I told you that in Simon rain gauge we have to measure the rainfall every day at 8:30 am. So every day we have to go near this station. We have to you can say bring out this bottle and pour that entire water into measuring jar and then measure the amount of rainfall. So every day we have to do this. Now see, we have some places which are not accessible. Okay, it is used in basically hilly areas, remote areas where we cannot go daily. It is used in hilly inaccessible areas. It is used in hilly inaccessible remote areas where we cannot go daily. Okay, in remote areas, in hilly areas, we cannot go daily on a daily basis. So at that place, what I will install this tipping bucket rain gauge, because signal will be continuously received from there only. There is no need to go there. Whenever rainfall will happen, sir, it will give you the signal, and from that signal we will get what kind of graph. Everyone try to comment. Everyone kindly comment, because this can be asked. They will ask you in examination like what sort of graph we get from tipping bucket rain gauge. Can you tell me? Everyone try to comment. See, this is important. And rainfall intensity versus time graph is nothing but hydrograph. If someone asks you like what is rainfall intensity versus time graph, you will say that is hydrograph. Okay, so intensity versus time graph is what? Hydrograph. Okay, I hope this is very, very clear to you. So basically what it is, used in hilly, inaccessible and remote areas where we need to where we can't go on a daily basis. So this is your tipping bucket rain gauge. Okay, so tipping bucket rain gauge gives intensity versus time graph, which is also known as hydrograph. This we will discuss later also. Okay, hydrograph is what? Intensity versus time graph. So this is clear. Now we'll move on to the next one. Which is your weighing bucket type. See, why the name bucket? Listen very carefully, because we have a bucket. Understood, sir? Now what will happen? This bucket will continuously receive rainfall. Okay, you need to understand here that this bucket will continuously receive rainfall. This bucket will see, you need to appreciate the fact that initially the water level will be less, and the moment you need to understand that rainfall will happen. When this rainfall will happen continuously, the level of water in this bucket will rise and the weight of this bucket will increase. If the weight of the bucket will increase, let me write here the mechanism. See, when rainfall is happening continuously, when rain is happening, then what is going on here? So level of water is increasing. When rain is happening, then level of water is increasing. When level of water is increasing, the weight of this bucket increases. Okay, weight of bucket increases. Sir, this is very, very simple to understand. And the moment the weight of bucket is increased, this spring will get compressed. This spring will get compressed. But you need to understand that with this spring, we have a pen attached. Okay. Try to understand with the help of this pen only. See, this is a pen which you can see here. As the spring is getting compressed, this pen will start moving. See, spring is getting compressed, this pen is moving. The spring will get compressed, this pen is moving. Okay. If spring goes up, pen comes back to its original position. If spring is getting compressed, this pen will move like this. Okay, like this. So let me write here, as the weight of bucket increases, spring gets compressed, and which in turn, you need to understand this compression of spring in turn is attached to a pen, and this pen starts moving. Okay, see, now what will happen? There is a pen, you can see this is a pen, and we have a revolving drum here. We have a drum which revolves. And on that drum, we have pasted a chart, or simply you can say we have mounted a chart paper. You can see this is a chart paper or a graph kind of thing which is pasted or mounted on this revolving drum. So this drum continuously revolves. This drum here continuously revolves. You need to understand this drum is continuously revolving, and the pen is moving here. So this pen will give you the graph like this. Okay, let me draw it with some another ink here. Yes, this one. So this pen will, when it will move up, graph will go up. When it will come back to its original position, graph will come down like that. Okay, so ultimately what will happen? See, but graph does not comes down. Why? Because the weight of the bucket will continuously increase. You need to understand that water is getting collected continuously. So the more and more the water there, more and more water is there, then you will see that weight of the bucket will increase. Yes or no? So more the weight, more the water, more the weight, and if more the weight, more the spring gets compressed, and if more the compression in the spring, you will see that this pen will start to rise. This pen will start to rise like this. Okay, you will see that this pen will start to rise. And how we are getting this graph? Because this revolving drum is continuously revolving around its axis, and a graph will be plotted on this chart which is continuously rising. That's why this graph is called as cumulative rainfall. Why cumulative rainfall? Because we are getting the accumulated precipitation. We are getting the cumulative rainfall. Why? Because in first hour, let us say 5 mm rainfall has happened. In next hour, let us say 3 mm rainfall happened. So obviously from the very beginning we have 8 mm, 5 plus 3, we have total 8 mm rainfall. So in this graph I will say that initially we have 5 mm rainfall, then we have total, now 3 more rainfall has added 3 mm, so total 8. Now let us say in the next hour we have 2 mm more rainfall, so obviously total is 10. So like this you will see that this is a cumulative kind of rainfall, cumulative kind of graph which we'll get here. I hope this is very, very clear to you. So ultimately what we get a mass curve. What is mass curve? Mass curve is nothing but cumulative rainfall with respect to time. We'll get the total rainfall from the initial point, from the starting time. If we get the initial rainfall from the starting time, that is nothing but your cumulative rainfall. In the first hour we have 5 mm, in the next hour if we have 3 mm rainfall, then total up to that time we have 8 mm rainfall, 5 plus 3, that is cumulative rainfall. So we will receive a mass curve which is nothing but cumulative rainfall data with respect to time. Yes or no? So we will get a graph. I hope this mechanism is fully clear to you. So when weight of bucket increases, spring gets compressed and pen attached to it starts moving, and pen moves. Actually this pen is you can say attached to this revolving drum. This revolving drum is having a clockwork mechanism here, because of which it is revolving. You need to understand. So pen moves and it draws pen moves to give mass curve on revolving drum or on chart. Okay, on chart which is mounted on revolving drum. Okay, on chart mounted on revolving drum. So I hope the mechanism is fully clear to you. And one more thing, see in this bucket, if you will remove this funnel, it will also collect snow. Yes or no? It can also collect snow. Yes or no? So it can also give you snowfall. Lecture notes you are unable to find. See, if you are unable to find lecture notes, simply go on PW app. Okay, on PW app you will easily find it. On PW app, all these notes are getting uploaded on daily basis. Okay, all these lectures also and all these notes also you will see there. Yes or no? Okay, so this is your weighing bucket type of rain gauge. I hope this is very, very clear to you. Now we'll move on to the next one. So is this clear to you? Everyone kindly comment that weighing bucket is fully clear to you. So let me repeat once. See, tipping bucket is giving you intensity versus time graph. Tipping bucket is giving you intensity versus time graph. I hope this is very, very clear to you. But weighing bucket is giving you what? It is giving you mass curve. It is giving you mass curve. Yes or no? I hope you have understood this fact. Now, see these are important points. Tipping bucket gives you what kind of graph can be asked in your exam directly. Where it is used, that can also be asked. Okay. Weighing bucket is giving you the mass curve. Everyone kindly comment which gives you the mass curve. Okay, what gives you the mass curve? Yes, Sushil, absolutely correct. You have understood it perfectly. This graph will be increasing, or when there is no rainfall. Obviously, when there is no rainfall, Sushil, the weight of this bucket will get constant, and obviously then spring will not get compressed, and at that time pen will be, you can say the pen will be not moving. At that point of time, in that state, pen will not be moving, and when pen will not be moving, you will see a straight line here. Okay, so the graph will be basically like when there is no rain, it will be constant. When rainfall is happening, it will increase. It will again become constant or it will increase. The graph will be like that. Absolutely correct. That means you have understood it brilliantly. Great work. Okay. So I hope you have understood this. Similar to this kind of weighing bucket, we have the third and last recording type of rain gauge, which is none other than your natural siphon type. See, natural siphon type is important because this is the common one which is used in India. If someone asks you like which kind of rain gauge is used in India as a recording rain gauge, you will answer what? See, tell me, we have a question here. The most common recording rain gauge used in India. Can you name the most common recording rain gauge which is used in India? Or you can simply say it is the standard measuring rain gauge of India. I will answer natural siphon is the one. Okay, natural siphon is the rain gauge which is used in India. Yes or no? So I hope this is clear to you. Okay, it is very, very similar to your weighing bucket. Yeah, wait a second. So it is similar to your weighing bucket. Sir, how it is similar to your weighing bucket? See, you should appreciate the fact that we have a float here. Okay, you can see this is a float. See, float is nothing but a plastic kind of thing. Obviously that float is giving you the level of water. See, whenever water level increase, the float which is suspended on that surface, that will also increase. Yes or no? You must have seen the float, okay, in your water closets where we have a flush. In the topmost portion, basically we have float system. Okay, see, let us imagine this is the surface of water and this is a kind of plastic material or simply the float. When this level of water will increase, this float will go up, and when the water level will come down, this float will come down. Yes or no? Okay, so now as rainfall is happening, what will happen in this bucket or in this system? More and more water will get collected. Yes or no? You can see from funnel water will come here and this float will start to rise. Okay, you can see that water will go inside this small system. You can see a system is there, a chamber is there. This is a float chamber in which more and more water will be there, and this float will start to rise. So I will write the very first point here. As level of water increases, as level of water increases, sir, the float rises up. As level of water increases, the float rises up. And you should appreciate the fact this is a similar kind of mechanism. Here the float is connected to a pen. You can see a pen here. Again we have a pen. Again we have a revolving drum on which, again we have a clock driven revolving drum on which your chart is mounted. Yes or no? You can see here. Okay, you can see here we have a revolving drum on which chart is mounted. This is a pen. Again similar kind of mechanism is there. So when this float will become constant, obviously this pen will give you the constant reading, and when this float will move up, obviously the graph will go in a increasing fashion. So obviously it is giving you again the mass curve similar to your weighing bucket type. Similar to your weighing bucket type, this will also give you mass curve. Okay, here there was a pen. Here there was a pen which is attached to the spring. Here we have a pen which is attached to the float, a similar kind of mechanism. Okay, but the advantage in your weighing bucket type is that it can measure snow also. Okay, in this bucket snowfall can also be collected. Yes or no? You should appreciate this fact. But in this float chamber we cannot collect snowfall. This will only measure your rainfall. The height is 750 centimeter. This is 203 centimeters. So all these things I hope is fully clear to you all. So as level of water increases, the float rises up. The pen attached to float starts moving. The pen attached to float, there the pen was attached to spring. Here the pen is attached to float. So pen attached to float starts moving and gives graph here. Okay, you can see here that pen start to move and give mass curve here. Here it will start moving and give, and it will give, and it gives mass curve on chart which is mounted on your revolving drum. So I hope this mechanism is fully clear to you. So it's a similar kind of thing. This is also giving you mass curve. This is also giving you mass curve, but this is important. Why? Because it is the standard recording rain gauge of India. So I hope this is very, very clear to you. Yes or no? Okay, Himanshu is saying water precipitation and precipitation reaction. See, Himanshu, this is not a chemistry class. Okay, I know it, but still I will not answer it because this is a hydrology class. Okay, so I hope natural siphon type is fully clear to you. So this is it. This is all which you need to remember from types of rain gauges. Okay, now we have to understand the rain gauge network thing. Okay, see, rain gauge network means what? If you want to measure rainfall in an area properly, you should have more number of rain gauges. Yes or no? You can appreciate this fact that if you want to measure rainfall in more, you can say with less error, if you want to measure more accurately, more precisely the rainfall, you should have more number of rain gauges. If you have more number of rain gauges installed in an area, then obviously you will measure the rainfall accurately. More accurate data you will get. Yes or no? So you need to appreciate that. See, rain gauge density is what? What is rain gauge density? See, rain gauge density is simply how many number of rain gauges we have in a given area. If we have more number of rain gauges in a given area, then we will say density is more. If we have less number of rain gauges in an area, I will say density is less. But if you have more dense network, if you have more number of rain gauges in a given amount of area, then obviously you will measure the precipitation or rainfall data with more accuracy, or simply you can say with less error. We will have less error in that data. Yes or no? Because more readings, more the number of observations, more the number of readings, we will have more accurate data. We will be more closer to your you can say true value. Yes or no? That's why if density is more, it is beneficial. Let me give you example of the country which is having the highest rain gauge density. Highest rain gauge density means the ratio of total number of rain gauges in the catchment, in the total catchment area. That is the meaning of density. Which country, or you can say which nation, is having the highest rain gauge density is none other than Israel. Okay, in Israel the rain gauge density, rain gauge network density is very, very high, and obviously the data which they collect is most accurate across the world. Okay, so obviously also we need to understand one thing, that Israel is having less geographical area as compared to India. Okay, so there they are managing it in a better way. So we are not concerned in that. Okay, we are not interested in that, but you should appreciate the fact that more the density, more the density, more the accuracy. Yes or no? Okay, so I hope this is very clear to you. Now the next point is that at least 10% stations should be recording type. What does it mean? See, try to imagine we have a catchment area. Okay, let us imagine we have a catchment area and we have different rain gauges here. Okay, try to imagine we have a catchment area. These are different rain gauges. So what will happen here? What will happen here? Try to understand. See, we have catchment area. We have different rain gauges located at different locations. Now let us imagine we have 10 rain gauges here. How many? Sir, 10. Now what is the 10% of 10? 10% of 10 is 1, which means that out of these 10 rain gauges, at least one is 10%. Okay, one is 10% of 10. Yes or no? So at least one should be recording type. At least one in this entire area should be recording type, and remaining 9 if they are non-recording, sir, no problem. Remaining 9 if they are non-recording, no problem. Sir, why we need one recording type? Can you tell me? See, we need one recording type because we have to understand in this area. See, if we have time variation, if we have timely variation or temporal variation measured in only one rain gauge, then it will give you the timely variation of rainfall in the entire area. Yes or no? There is no need to install recording rain gauges everywhere. Only one recording rain gauge, only one recording rain gauge in this area will give you the exact idea so as to when rainfall has exactly occurred. Has it occurred at 11 a.m. or it has happened at 2 p.m. like that? Okay, only one rain gauge is sufficient to give you the temporal variation. Only one rain gauge is sufficient to give you the timely variation. Yes or no? There is no need to install all the rain gauges, okay, as recording rain gauges. Otherwise it would not be economical. Yes or no? Otherwise it won't be economical. I hope this is very clear to you. So at least 10%, at least 10%. So I hope this thing is very clear to you. So this is also a codal provision which is mentioned in IS 4987. See, this is a code of this code is basically your measurement code. Okay, this code is basically your related to your rain gauge. Okay, so this is your rain gauge code. Now we have three codal provisions from your Indian codes. Okay, so according to, see, you all know that in Indian subcontinent we have basically three kind of land masses. In Indian subcontinent, basically, sir, we have three kind of land masses. Okay, sir, what are those? Can you tell me? Listen very carefully here. See, you must have seen plain areas. You must have seen flat lands. Yes or no? Have you seen it or not? Then you must have also seen plateau region. You also must have seen plateau region, and you must have seen hilly regions. Basically, we have three areas in Indian subcontinent. Basically, wait a second. Let me drink some water. Then I will proceed. Yes. So now you need to understand all these three kind of areas. See, plain areas generally are at lower level. You know, this is plain region. What is plateau? Plateau means we have a higher level, then we have flat land, and this is a plateau kind of thing, and this is hilly area. Okay, you know, hilly areas, it is difficult to live in hilly areas, you all know this. So this is hilly, this is plateau. Plateau is having a higher elevation as compared to your plain areas. See, basically the central part of India is your plateau region. So based on these three kind of regions, we have the very first one as plain area. I hope you have understood that. Then we have region of average elevation 1000 meter, which means we have a plateau region. Okay, so region of average elevation is 1000 meter, so that is plateau region. Then at last we have hilly areas. Generally hilly areas receives more rainfall, that you should remember. Hilly areas generally receive more rainfall as compared to your flat or plain lands. Okay, so in these three regions, code is giving you, mentioning you how much stations you should maintain, or you stations, how many stations should be there in a given amount of area, or simply code is mentioning amount of density. See, if more rainfall is there, the area in which more rainfall is there, there we should have more number of rain gauges. Yes or no? Yes or no? If we have more rainfall in certain area, there we should have more number of rain gauges. Yes or no? So Here they are saying the code is specifying that in hilly areas which are receiving more rainfall, at least one station should be there in 130 kilometer square. In every 130 kilometer square, at least one station should be there, yes or no? And approximately 4 times less number of stations. You can see plain areas are having one station only in 520 kilometer square. Here we have in hill area 130 kilometer square, and here in plain areas we have 520 kilometer square. See, 520 kilometer square is 4 times of 130. So here in 4 times area we have one station. That means density is less in plain areas. If someone will ask you like what is the density, based on density, you can say that plain areas have less number of rain gauges, then also it would be fine. In plain areas, the amount of rain gauge density which are required is less as compared to your plateau region. Okay, plateau region, or simply the regions which are having average elevation of 1000 meter. There we have one station in 260 to 390 kilometer square, and in hilly region we need highest number of rain gauges because rainfall is more. More the rainfall, we need more number of rain gauges. I hope this is very clear to you. More area, more rain gauges. Okay. Also, you need to appreciate one fact here. You can remember this data very simply. You all know table of 13. Okay. 13 ones are 13, 13 twos are 26, 13 threes are 39, and 13 fours are 52. So 13 table it is only 13, 26, 39, 520. Okay. So you can remember this data very simply. I hope it is very clear. Let me not remove this diagram. It should be there with annotation. So I hope this entire slide is very clear to you. Okay. So this is your data which is given to you according to code. So I hope this codal provision is very clear to you. Okay. Wait a second. Okay. So adequacy of rain gauge we will discuss in the next class. Okay. So I hope we are done with this today. Yes, this is it. And this I have already told you that this is the last line that we are going to discuss today. We'll catch up tomorrow with the next class. Okay. So now what this is saying, adequacy of rain gauge station. See, number of rain gauge in a catchment must be sufficient. I have already told you this thing. If we have more rain gauge, and if we want to measure the rainfall data more accurately, listen very carefully. If we want to measure the data more accurately, then the number of rain gauges should be high. Okay. So how many number of rain gauges exactly we should have? How many number of rain gauges we should exactly have? So the error in precipitation is not more. If we want to minimize the error, if we want to control our error, if we want to be, if I want my data to be more accurate, then how much number of rain gauges we should have, that we'll study tomorrow, and we'll also solve a question on it. Okay. So number of rain gauges in a catchment area must be sufficient. It must be adequate in number so that error is not more than accepted value. Error should be less than a given value. Error should be within limits. Error should be below permissible limits. Why? Because we want our data to be accurate. We want our data to be precise. Yes or no? So how many exactly number of rain gauges we should install in our catchment area, that we'll discuss tomorrow. We have a formula to it which depends exactly on precipitation data. Okay, how much variation in that data how much variation is there, so that depends on that. So we'll discuss that tomorrow. Exactly optimum number of rain gauges we have to find out. Okay, optimum means what? Neither less nor more. Okay, we have to balance out between economy. If you will see, there is one concept which you need to understand. If you want to bring down the error to zero, if you want to bring down the error to zero, or if you want to be infinitely accurate, then the number of gauges, rain gauges which are required are infinite. Okay, and obviously you cannot install infinite number of rain gauges. Okay, if you cannot install infinite number of rain gauges, but yes, there is a balance to it. Okay, exactly as to how many number of rain gauges we have to install so that the error is not beyond a value, beyond a permissible value, that we need to find. Okay, so we have optimum number of rain gauge formula so that error is not very less or very high. Okay, it is somewhere in between, so that our work is done, so that the installation is not going very at a very high cost. It should be economical, and also error should be less. So that we'll discuss tomorrow. So I hope it is very clear to you. Okay, yes or no? So we'll catch up tomorrow with this from here only. So what we have discussed today, we have basically discussed like some codal provisions as to how much should be your rain gauge density and where the best rain gauge density is found in your which country. That also we have discussed. We have also understood one point, that in hilly areas wherever rainfall is more, see, in hilly areas, in coastal areas, you all know what coastal area is. The area which is near to your sea, the area which is near to oceans, there you have more rainfall. There also we will require more number of rain gauges. Okay, that we have understood. We have studied natural siphon type, which is the recording rain gauge of India. Then we have also understood weighing bucket type. This also gives you mass curve, and natural siphon, the Indian one, also gives you mass curve. Mass curve is nothing but cumulative rainfall versus time. See, remember this. This is very, very important. In examination, they can ask you like natural siphon type gives you what sort of curve, which sort of graph they give you, that you have to remember. I hope this is very, very clear to you. Yes or no? So this is your natural siphon. This is your weighing bucket. Then we have tipping bucket rain gauge. Okay. So tipping bucket rain gauge is what? Tipping bucket rain gauge, I've already told you that in this we have a pivot. Uh, Across this pivot, you can see that this fulcrum is balanced and it will tip over as the bucket is getting emptied again and again. Okay. It gives you what kind of graph? Everyone kindly comment. Tipping bucket gives us hyetograph or intensity versus time graph. This you have to remember, and we use it in hilly and remote areas. Then we have the non-recording type Simon rain gauge, the only one which is very, very important because it is used in India. Every day rainfall is measured at 8:30 am. This we have also discussed, and it should be placed in an open area. No object should be near to it. No object which is has to be placed near to it, 30 meter or twice the height of obstruction. See, this is the codal vision which you have to remember. Okay. So we have basically discussed that, and also we have discussed different forms of precipitation. So I hope all the forms are also very, very clear to you. Rain, snow, these are different forms. So average density is 0.1 gram per cc, and sleet is mixture of snow and rain. See, I have missed one point here. See, this snow is not opaque. This is transparent. This snow is not opaque. See, the refrigerator, the ice cubes that you see in your refrigerator is somewhat translucent or transparent. Okay, is somewhat translucent or transparent. You can also search the image of sleet on Google only. Okay, you will see the small, you will see small ice cubes. In hydrology we use IS code. No, dear Ankit, it is hailstorm. Okay, hailstorm is, which is your the term which you are asking is hailstorm. Okay, in this you have large pellets of you can say snowballs which generally falls on the ground. Okay, snowballs we have. So it is ranging in, see, generally the hailstorm size, the size of one piece is more than 8 mm, but it is ranging somewhat between 5 to 50 mm, and it is very, very destructive. Okay, because it falls with a very high force, not at all favorable. So this is it. So all the forms are very, very clear to you. So I hope it is clear. So we'll end our lecture today and we'll catch up tomorrow. Okay, so till then, take care, stay blessed. I hope you are enjoying the lectures. Also, you can find the PDF which are attached on your PW app itself. Okay, on PW app, select your goal as gate, and there you can see the PDFs in your this gate 2024 course. Okay, that is cloudburst, dear. Okay, cloudburst. Cloudburst means Cloudburst means what? That cloud has completely saturated with water and it has bursted apart. Okay, and obviously when it will burst, it will give you too much of thunder, and precipitation will happen in a, you can say, at a very high intensity. Okay, heavy rainfall you will see. Heavy rainfall you will see there. Okay, which book to refer for topic wise PYQ? See, standard book from which I am teaching is K. Subramanya. Not important for you all because I am teaching all the relevant points. Okay, there is no need to refer any kind of standard book, but still if you want to refer, K. Subramanya is the one. And if you want to refer for PYQs, you can purchase any publication PYQs. Okay, any publication PYQ you can take from there, you can solve PYQs. See, PYQs are only important if you are able to solve it from yourself only. There is no need of buying you can say any kind of PYQ you can get it. Okay, only thing is there that you should have all the 30-year PYQ only. Okay, if all the 30 years previous year questions are there, then there is no issue. Okay, Sushil, so you can buy any publication previous year questions. Yes, Priyanshu. Yes, obviously cloudburst has happened in Kedarnath once in 2013, I guess. 2013 or 2014 it was. Yes, I hope you remember it. It was a great incident. Generally it happens, it is not very common event. Generally it happens rarely. Okay, so we'll discuss that. Okay, return period concept we'll discuss. You will relate it very beautifully here. Sir, you were not there in Vishwas Divas. No, I didn't went. Actually, invitation was there, but obviously the destination was very far from a studio, so that's why I focused on our today's class. Okay, otherwise the class would have not happened. Okay, but yes, I saw that entire thing on YouTube itself. Okay, and many of my colleagues are also there, so no issues in that. Okay, so stay blessed, take care. We'll catch up tomorrow and we'll continue with this lecture. Okay, take care everyone. Good night.